Hi everyone. Today we are going to do your activity 29 and 30 review over rational expressions and rational equations. So let's go ahead and get started. All right, so first we're going to multiply or divide these rational expressions. Sorry about that. And then show work and factor. List any restrictions for each denominator. So let's look at this first question here. We are multiplying, but we need to factor this out first, right? So let's go ahead and do that. So this would be, let's see, -5 plus 3. 3 times -5, -15. 3 minus 5, -2. Perfect. Those we don't need to factor, and that's already factored. Okay, so now that we have everything factored, let's go ahead and list out what x cannot equal. So that's going to be the restriction part. So x cannot equal -3. Okay. And then now we can go ahead and cancel out our like terms. So I have x plus 3 in the numerator and denominator. X minus 5, it's by itself. 8 divided by 4 is just 2. So I'm left with 2 times x minus 5, and there's nothing left in the denominator, so this is my final answer. And because there's nothing left in the denominator, there's no other restrictions, so that's it. Okay? You can say that this is 2x minus 10 if you want, but it's not necessary. All right, number 2. Let's factor everything out. It looks like we're multiplying, but let's go ahead and factor everything out. Here, x plus 3, we can't factor that. This 10x plus 20, that's a GCF of 10. So I'm left with x plus 2. Remember, GCF is always the first step of factoring, so always look for that if you get stuck. I have an x plus 2 here. Down here I have x plus 1 times x plus 3. If I FOIL that, I'll end up back there. So now I can go ahead and multiply these out. So I have x plus 2's, I have x plus 3. I'm not left with anything in the numerator, so that's just a 1. If you were to say 0, 0 divided by anything is 0, so then you would say that all of this stuff is gone, but it's not. I still have a 10 and an x plus 1 in the denominator. Okay, so make sure you leave the 1 on top. If you say that's 0, 0 divided by anything is 0, so that would be gone, but it's not gone, so be careful. Oh, and I forgot to state my restrictions. Whoops. All right, so x cannot equal, let's look back at the original problem at my denominators. So x cannot be -2. -2 plus 2 is 0, and we don't want that. X cannot be -1, and x cannot be -3. I suggest doing your restrictions before you simplify. I was just being silly there, so sorry. All right, number 3, looks like we're still multiplying. Let's factor everything out first. That's good. I have a GCF of 8 here. That looks good. Let's factor this numerator out. X plus 1, x plus 7, it looks like. Yeah, that looks good. All right, so let's write our restrictions. X cannot equal -1. And if I plug a 0 in for x, 0 squared is 0. 8 times 0 is 0, so yeah, can't have a 0 there. All right, that's where that 0 is coming from, is from that guy. All right, let's go ahead and simplify now. I have an x plus 1. Alrighty, it looks like, I'm going to kind of cross those out because this is what these equal. I have an x in the numerator and 2 x's in the denominator. So this one's going to go away, and I'm going to just be left with one of them right here. So I'm going to be left with 1x in the denominator. This x plus 7 stays in the numerator because there's not one in the denominator. Then I have this 4, 8, and this 8. So I have 4 over 8 times 8. So let's figure out what 8 times 8 is. If you don't know, it's 64. And so you're doing 4 divided by 64, which is 1/16. So that would be the 1/16. That make sense, guys? And again, x cannot be 0, so we have listed all of our restrictions. Okay? All right, number 4. We are dividing. So like I said, let's list our restrictions first and factor everything out. So in this numerator, I have a GCF of x, so I have x minus 2 left because I take out an x and an x there. Over here, I have a GCF of 3. Okay. And it looks like in my denominators, only x can't be 0. So let's list that guy. Now remember, when we're dividing by a fraction, you're really multiplying by the reciprocal. So I'm going to rewrite this as x times x minus 2 over 6. So all I did was rewrite this guy, multiplied by the reciprocal of this. So I'm just going to flip it. So x over 3x minus 2. Okay, see how I just flipped those? All right, and then notice we still have to list restrictions in this form too. X cannot be 2. So those are my 2 restrictions there. Okay, and then now we can simplify. So it looks like I have x minus 2 in both the numerator and denominator. I'm left with x squared in the numerator. 6 times 3 is 18, so x squared over 18. And there's no restrictions there, so I don't have to add anything to my list. Okay? All right, number 5. Let's see, we're dividing. Let's go ahead and factor everything first. So that will be negative 4 plus 2. Yep, that looks good. Over here, we have a GCF of 8. We have a GCF of 2. And over here, this would be x and x. Let's see, 3 and 4, both plus. Okay, hopefully you guys are good with your factoring now, because that's a lot of this. All right, so let's list any restrictions. X cannot equal negative 3 and negative 4. If I plug in a negative 3 plus 3 is 0, negative 4 plus 4 is 0. Okay, so remember you're doing the opposite sign here. Okay, and then remember you're multiplying by the reciprocal. So I have x minus 4 times x plus 2 over 8 times x plus 3 times the reciprocal of this fraction. And then let's see, let's check our restrictions. X can't be negative 3, x can't be positive 4, and don't have that one in there. 4 minus 4 is 0. So now I have all my restrictions. All right, now let's go ahead and divide out any like terms. So it looks like I'm left with x plus 2 times x plus 4, all divided by 8 times 2 is 16. Okay, and these were my only restrictions. There's nothing else to add down there. All right, number 6. Let's factor this all out. So x, am I going to use 3 and 2 or 6 and 1? This one's tricky. This factoring is tricky when this is a 6 and that's a 5. I think I want 6 and 1 because let's do negative 6 plus 1. 1 times negative 6 is negative 6. 1 minus 6 is negative 5. Yep, that looks good. If you use 3 and 2, it won't work. You'll see that if you FOIL that back out. Then down here I have a GCF of 5. All right, over here this would be x, let's see, 4 and 1 minus 4 plus 1. Yeah. Then I have a GCF of 7. Alrighty, so we're good. Now let's list our restrictions. X cannot equal negative 3 and negative 3. I don't need to write it twice. It's already listed. So now I'm going to multiply by the reciprocal. Okay, so these are gone. These are gone. Oh, I forgot to list my restrictions. Darn it, sorry. So x can't equal negative 3, x can't equal negative 1, and x can't equal 4. Then cross out your stuff. Sorry, guys. My fault, my fault. All right, so the x plus 1s are gone, the x plus 3s are gone. I think that's it, actually. Yeah. So I'm left with 7 times x minus 6 over 5 times x minus 4. And that would be it there. And those are your restrictions. So don't forget to double check that you've listed all your restrictions. I've been silly now twice, but I've gone back and remembered them. Okay, but make sure you guys take care of that beforehand. Okay, now we are going to perform the indicated operation and show our work and include any restrictions on x. So we're actually doing what we did above, except this is addition now. Remember, with addition, you have to have common denominators, okay? So addition and subtraction, you need common denominators. Okay? Alrighty, so let's see here. This is x minus 2 and x plus 5. Those are clearly not the same. So my least common denominator, let's figure out what that is. It looks like I need an x minus 2 and an x plus 5. They both only occur once, so they each have a degree of 1. So now I'm going to look at what's missing from this fraction. What do I need to multiply that by? Looks like it needs to be an x plus 5 because I already have the x minus 2. Remember, we like to do it to the top and the bottom because that really equals 1, and now we're not changing the problem. All right, this has the x plus 5, so now this needs the x minus 2. And then now do you guys see how we have x minus 2 and x plus 5 in both denominators? So that means now I can combine my numerators together. Okay, so this will give me 2x squared, whoops, right, plus 10x, 2x squared, 10x, yep, plus 7x minus 14 all over my common denominator of x minus 2, x plus 5. It doesn't matter which one you write first and second. Okay? All right, now combine my like terms in the numerator. So 2x squared plus 17x minus 14 all over x minus 2, x plus 5. And you want to see if you guys can factor this out. It looks like we can't. Let me grab a separate sheet of paper and try that real quick. Doesn't look like we can though. So 2x, x, factors of 14 would be 7 or 2, 14 and 1. That's going to be too big. That's 14. This will give you 14x. This will give you 2x, but that doesn't add to 17. So yeah, we can't factor that. So that would be your answer. Sometimes this isn't factorable, okay? Now, I did, again, forget to include any restrictions on x. So we need to say x cannot equal, look at the LCD that you guys started with. So x can't be 2 or negative 5 because those numbers would make the denominator 0, 2 and negative 5. Make sense? Okay, number 8. First we need to factor this out to find the least common denominator. So this will be x plus 2 times x plus 2. This is x plus 2, x minus 2. That's a difference of 2 squares. All right, now let's find our least common denominator. So we know we have an x plus 2. And it occurs twice here and once here. So this has a degree of 2, because another way to write this is x plus 2 squared, because it happens twice. So that has the higher degree, 2 versus 1, so that one's in the least common denominator. And then we also have an x minus 2. So there's our LCD. This means that x cannot equal negative 2 and 2. Okay? All right, and then let's see what's missing. I'm going to actually do this in a separate color to make it a little easier to see. Whoops, struggling over here. Okay, so this has the x plus 2 squared, so I need the x minus 2 over here. This has the x minus 2, one of the x plus 2s. It needs another x plus 2, so now it's got both of them. Okay. And then we go ahead and FOIL this. Oops, let's do this. Alrighty, so I get x squared minus 2x plus x 2x minus 2. And I'm going to make this a plus sign and distribute the negative. So I'm really multiplying this negative 2 by x, which is negative 2x minus 4. You don't have to, but I like to do that so I don't forget about any negatives. I don't make any silly mistakes. Okay? All over the denominator of x plus 2 squared times x minus 2, which is your LCD. And the reason why we're able to combine the numerators is because the denominators are the same. All right, now we got to simplify that numerator out. So we get x squared negative 1 minus 3x. Negative 2 minus 4 is negative 6, all over x plus 2 squared, x minus 2. Factors of 6 that add or subtract to get 3 is not possible, so that's it. And these are restrictions, nothing changed there. Okay? Alrighty, on to the back. Alright, we've got a subtraction problem here. So I like to make this a plus and change that to a minus. I like to distribute that negative just so I don't make any silly mistakes later on. But let's go ahead and factor out this denominator. So negative 7 plus 2, right? Yes. All right, so the LCD would be x plus 2 and x minus 7. There's x minus 7 in both of these, and there's x plus 2. X minus 7 occurs once in both, so that's just a degree of 1. So this already has the least common denominator. This does not. This is missing the x plus 2. Alrighty, now I'm ready to simplify this. So now these have common denominators, right? So this is just 10, because we didn't do anything to it. Minus 2x minus 4 all over x plus 2 times x minus 7, which gives me 10 wait, no, that's 6. Hold on, mistake. I'm going to write the x term first. So this gives you negative 2x, 10 minus 4 is 6. There we go. Let's see, x plus 2, x minus 7. Now, you could factor out a 2 here, take the GCF out of 2, or even negative 2, so you get x minus 3. But notice, nothing cancels, like your factors don't undo each other. So you could leave your answer in this form or this form. They're both correct. I like to factor it just to see if anything simplifies down further, but I would accept this too. And real quick, we do need to state the restrictions. You can get that from your least common denominator. So x cannot equal negative 2 and 7, because that would make the denominator equal to 0. Okay? All right, one more addition problem it looks like we got over here. So we are going to factor this out. Let's see. No, minus 2, minus 1, positive 2, yep, negative 3. This has a GCF of x, so x minus 2. Alrighty, and then our least common denominator would be x. We have an x minus 2 in both of these, and we have an x minus 1 in both of these, or just in one of those actually. Okay, so there's our LCD. So x cannot equal 0, 2, and 1. Alrighty, so let's see what's missing. This has the x minus 2 and the x minus 1, so just the x is missing here. This has the x minus 2. This is missing the x minus 1. Alrighty, now they have common denominators. Let's do our thing. X squared plus 3x minus 3 all over x times x minus 2, x minus 1. You cannot factor out, you can't find factors of 3 that add or subtract to get 3, so that's actually simplified all the way. And those are your restrictions. Okay? And then, so that's the adding and subtracting. And then the very last thing that we learned in this lesson was the equations. So solve the equations, show your work, include any restrictions on x, and list, check for extraneous solutions. Sorry. Okay, real quick, I just want to check something really fast. Alrighty. Okay, yep, we're good. Alrighty, so here we go. Number 11. Remember, our goal is to get rid of the denominator on these. So goal, get rid of your denominator. So we have to multiply everything by the least common denominator. So let's find that first. Looks like all of our denominators are like already factored. So it looks like the LCD is just x and x plus 2. So that means that x cannot equal 0 and negative 2. So I'm going to multiply everything by that. So then the x's cancel here, the x plus 2 cancels here, and these x's cancel here. So now I'm just going to simplify this. So 2 times x is 2x plus 4. And realize that x is gone, so the denominator is gone. That's what I wanted. This is really a negative 1 times x, so negative x. And then we have 3 times x. Oh, whoops, equals. Whoops. Equals. There's an equal sign there. Sorry, guys. 3x plus 6. Sorry, just checking my work. Okay. Combine your like terms. 2x minus x is 1x plus 4 equals 3x plus 6. I'm going to subtract x from both sides. So 4 equals 2x plus 6. I'm going to subtract 6 from both sides, get x by itself. So I get, whoopsies, gotta move over here. Negative 2 equals 2x, and then I'm going to divide by 2. So x equals negative 1. Let's double check to make sure that works. So let's see. 2 over negative 1 plus, oh whoops, that was a minus, but I did change it to a plus. So let's do this. Negative 1 over negative 1 plus 2 equals negative 3, and 3 over negative 1 is negative 3. So that does work, and it's not in our restrictions, so we're good. Remember, if this term ends up in your restrictions, then it doesn't work. Alrighty, 2 more. Number 12. What's our least common denominator? We don't have to factor anything, so it looks like it's just x and x minus 1. That's it, right? So that means x cannot equal 0 or 1. So let's multiply everything by that least common denominator. Whoopsies. X times x minus 1. X times x minus 1. Alright, so the x minus 1s are gone. X minus 1s are gone. X is gone. Alright, so I've got x times x is x squared equals 1x. So that's just x. And then plus 2x minus 2. Okay? And then I get x squared equals 3x minus 2. X plus 2x is 3x. Because this is a quadratic, we need to get this set equal to 0. So I'm going to move this 3x over. So I'm going to subtract 3 from both sides. And I need to move this 2 over, so I'm going to add 2. And remember, when you get a quadratic, you either have to factor it or use the quadratic formula. I'll make sure that it's just factoring, though, so go ahead and factor that out for you guys. So we got 2 and 1, both negative. But multiplied is positive 2. Minus 1 minus 2 is negative 3. Okay, we're good so far. So we get x equals 1 and x equals 2. Red flag, red flag. What do you guys see here? This 1 is a restriction, so this is not a solution. Bad, okay? Let's make sure the 2 works, though. So let's see here. So I don't even need to check the 1 because it's in the restrictions. All right. So let's plug in this 2. Right? Is that what number? Yeah, 2. Okay. So alpha 2 over 2 minus 1. So 2 equals 1 over 2 minus 1 plus 2 over 2. 2. 2 equals 2. Yay, we're good. So that is a solution. Alrighty, last problem, guys. Number 13. So it looks like our least common denominator here. Oh, wait. Oh, this is a fraction set equal to a fraction. We can just cross multiply this, guys. Work smarter, not harder. Okay, let's do that. Before we do that, though, let's find our restrictions. So x cannot equal -2, right? -2 plus 2 is 0. And I'm going to write this off to the side over here. 2x plus 4 equals 0, so 2x equals -4. When you subtract that, and then I'm going to divide both sides by 2. So x cannot equal -2. Oh, I already have that in my list, so I'm good. Phew. Okay. All right, so let's go ahead and cross multiply this. This looks like fun. So you're doing 3 times the 2x plus 4 and the x plus 2 times the x minus 3, because that's the cross multiply, okay? All right, so this gives me 6x plus 12 equals x squared minus 3x plus 2x minus 6. Combine like terms, 6x squared, whoa, that's just a 6x, I don't know why I said squared, plus 12, so 6x plus 12, sorry about that, equals x squared. -3 plus 2 is -1x minus 6. And I want to keep this x squared positive, so I'm going to subtract the 6x, and I'm going to subtract the 12 over to this side. Because remember, when it's a quadratic, you got to set it equal to 0 like we did over here. So this whole side will be 0 now. So we get x squared minus -1 minus 6 is -7x. -6 minus 12 is -18x. Or no, just -18, sorry. Equals 0. Now we're going to factor that. 9 and 2. -9 plus 2. -18. Yep. So x equals -2 and x equals 9. Uh-oh. X can't be -2. So he is a no-no. Let's make sure the 9 works. So, whoops. Alpha, nope. What am I doing? There we go. 3 over 9 plus 2. 3 over 11. 9 minus 3. 2 times 9 plus 4. Yay, 3 over 11. Woohoo! Okay. So on all of these problems, I forgot to box this off, sorry. X can't be those numbers. You should have an answer with your restrictions, even on all the simplifyings on the front and stuff too. Okay, guys? If you have any questions, please come in and ask. And yeah. All right, study hard. See ya.